everybody. Today I will introduce a new product which developed by TinyRFSG. The name is RF detector. RF detector have hardware and software product. But now today I will only introduce the software product. RF detector like TinySA and TinySA Ultra from standalone equipment to the internet equipment. In the software, there are two parts. One is RF detector analyzer and one is RF detector recorder. This is recorder and this is analyzer. Recorder can record the real-time TinySA and TinySA Ultra spectral trace and do the real-time alarming. And the recorder and the analyzer, it can deep research the trace data and see the historical data. Okay, let's introduce the background. TinySA and TinySA Ultra have been widely used in various electromagnetic monitoring scenarios around the world. Due to their excellent performance and good price, they are very popular among the user. And currently, TinySA and TinySA Ultra are mostly used as a standalone equipment. There has been no remote automatic control software available, so they have not been able to benefit from the internet. Their standalone operating system can only capture real-time screenshot or trace, but cannot record historical data or perform deep analysis. So you can see now most software and hardware try to hack this internet. But TinySA and TinySA Ultra is really good RF equipment, so we must let it also benefit from the internet. The existing host software can only display real-time spectral trace and cannot meet the requirements for real-time data alarming, historical data recording, or analysis. Now there are two kinds of the software which used with TinySA. So you can see this is a TinySA app and this is a Qt TinySA. Qt TinySA is written by Qt Python. The TinySA app has not been updated for many years. When we developed the TinySA, we written the TinySA app, but TinySA app has not updated for many years. And the Qt TinySA, in fact, I don't like to use it. I think it's not good for the RF engineer. And in the future, the app detector will be also compatible with all other small spectral analyzers, such as SA6, SA8. The RF detector recorder saves spectral data while performing real-time alarm detection. RF detector analyze the data file. RF detector recorder support multi-platform, including Windows 10, Windows 11, Raspberry 4, Raspberry 5, and Linux. RF detector analyzer can only run on Windows, so you can see the RF detector recorder can run a lot of different platforms. So when you use it, you can use a very small computer, just like a Raspberry, to control your TinySA and TinySA Ultra. You can bring it to a Joe with the battery and recorder all the spectral. Next, then I will do some real time, and then I will do some real operating on these two software. Hope you can get some useful information, and later you can use by yourself. Okay.
Okay, this is advertisement time. TinyRF Equip Company. Welcome to our website of TinyRF Equip, which covers and introduces RF test equipment, device, and related RF modules. Our products are mainly used to meet the needs of basic wireless product testing, home radio test amateur, and students' learning needs. Our company is in China, Tianjin. This city is near Beijing. So we try our best to give your RF products with best value for money and high quality. All the world customers can buy our products in Taobao or directly from our company. RF equipment are sometimes very complex, so we can learn from the YouTube Bilibili with our good training course. If you buy in our products, we will also give you a best smart by WeChat with audio and video. Do not hesitate to directly contact us in Taobao or mobile phone or email. So you can see this is TinyRFEquip.com is our website. Bilibili account TinyRFEquip. Taobao shop TinyRFLive. Pay attention, this is TinyRFLive. Email and YouTube TinyRFEquip Terry. At present, the products include TinySA, TinySA Ultra, LiteVNA V2, LiteVNA V3, LiteVNA, LibreVNA, Detector 2 Near Field Pro, TinyRFSG Training and Consulting. Except the product, we also do some project. Our engineers have experience working in our field. Have undertaken various types of art projects such as new art product development, art signal monitoring, wireless electromagnetic propagation, etc. If you are interested, you can send us email or call us directly. We have some project photos. This is rhythm monitoring project. This is developed by ourselves, and this is wireless electromagnetic propagation. This is a transmission part. This is the receiving part. Okay.
Hello everyone, now I will show you how to use the RF detector recorder and RF detector analyzer. At the screen, at the right bottom, you can see there's two TinySA spectral analyzer. One is TinySA Ultra and one is TinySA. I use Type-C and USB cable to connect with the Ultra and the PC laptop. So next I will show you how to control this TinySA Ultra. Okay, open the RF detector recorder. Okay, you can see it begin to scan automatically because it detects the TinySA Ultra automatically, and this is a database file. All is the DB OK and the device OK, and the scan data is the scanning. In the future, if you want to upload your trace data to the cloud or the server, you can select this, and but now it's still on development. So we can see the scan plot. Now it recorder FM band, GPS L5, control, channel, and this is all based on my Singapore drone show. The L1, okay, L2. Now we back to the alarm list. So we can see this totally 5 frequency bands to monitor. One is control, GPS L1, L2, FM, and L5. If you want to edit the alarm list, you can first stop the scan. And now I just like the FM. I edit it. So you can see the device type is TinySA Ultra, name FM, start frequency, end frequency, loop, and loop, and the alarm voice time. If it gets real-time alarming, it will output to the music box or other light, so it will alarm for 30 seconds and point 1000 RBW, harmonic, and spur remove max single runtime. If the one scan exceeds the 2 seconds, it will think the TinySA Ultra or TinySA is died. It will reboot the frequency, reboot the software. Okay, there's three kinds of the alarm. One is spur alarm. The second one is the channel power alarm, and the third one is the STDV alarm. This one STDV alarm is a static alarm. So the first spur alarm means you need to set the spike dBm. If the spur point exceeds the dBm with the total number, it will alarm. And the channel power from the start frequency to the end frequency, the total channel power, if it exceeds some spec, you will get the alarm. And the STDV also the same. If you do not know how to setting the alarm spike, you can do the calibration. So you can see the STDV, it's a 10.05, and the channel power is minus 52.40, and the 3 maximum point is here. So you can alarm, update alarm, back to the edit. You can get the, so you can see this, and this. You can setting your own alarm limit by this calibration done at the back. So we can continue to scan. So it's changed to the scanning, and you can see the scan data. So this is a Y1. You can see this interfere L2 FM and F5. Okay, so if you want to do more detailed operating, you can see the user menu. Okay, we stop the scan and home, back, close. After you do the recorder, you want to analyze the historic data, you can open the RF detector analyzer. Open the database, so you can see there is several alarm list. Check the FM, so you can find there are totally 26 recorder. One, you can play it. You can see the change. Stop it. You can see the alarm recorder. So there's a no alarm recorder because I did not setting the alarm spec. Calibration. You can see there's a total 5 calibration. Check in the different time and the test time distribution. You can see we do the FM alarm check in the for April 12 and today. So we can check. If you want to do the detail inquiry, you can use the below limit, the time limit, channel power, DDV, summary or not. If you focus on special point, frequency point, you can also use this to inquiry. Okay. This point, this blank, you can see the top fare maximum point with its frequency and amplitude. And you can also get some useful information here. Okay, thank you. Later, I will control the TinySA Ultra with the Raspberry and use the RF recorder in the Linux. Hope you can get more information. Thank you.
The last, I will show you how to use the Raspberry Pi to control the TinySA. Okay, you can see this is TinySA Ultra. This is CM4, one can of the Raspberry, and this is RF detector recorder.
This is a classical desktop of the Raspberry. Now I run the code. You can see the database is okay. The TinySA Ultra equipment data is okay. Now the scan is ideal. So I begin to scan. So you can see the FM, L1, L2, and L5 of GPS begin. So you can see, okay, this spectral trace is changed, and it's same with this TinySA Ultra. It got the same shape, and it also written in the database, and the data is scanning. And you can back, and you can edit this. I can stop scanning. So you see the scan data is ideal, and you can see in the TinySA Ultra it stop scanning and remain the last status of the alarm list. So it's okay. If you want to use it on your own Raspberry, please contact me. I will let you work. Thank you.